So intrusive and extrusive, so key example of an intrusive rock is granite, there's a picture of it, and the main examples of an extrusive rock is rhyolite, there's a picture of that as well. So an intrusive rock is one that's an igneous rock that's formed when magma cools, solidifies within the Earth's crust. So it cools very slowly, which creates large rocks, and so all the rocks can be classified according to their shape and size, so it's easy to tell the difference between the two of them. And so extrusive rocks, which is the other type, they're igneous rocks again, which are formed at the crust surface from slow cooling of the magma, which creates it creates smaller and fine-grained rocks.
Right, well, magma in intrusive volcanic features cools, crystallises and solidifies into igneous rocks below the surface. The resulting features may then only become part of the landscape once later erosion removes the overlying rocks. Right, batholiths are massive in comparison to the other intrusive features. Dikes, sills and laccoliths will feed off the batholith's magma before it solidifies. The extreme heat of the batholiths alters the rock structure, and that's called metamorphosis.
So dikes, they form where magma solidifies in a vertical crack called fissures. And they often form in groups called swarm. Dikes can either consist of easily eroded or harder eroded material. If they're easily eroded, they can create ditch-like features in a landscape, and if not, they can create wall-like features. And they're found on the Scottish Islands.
So hot springs, they are not under pressure and they're common in volcanic areas. So it's produced by the emergence of geothermal heat and groundwater from the Earth's crust. So they're geothermal. Oh, I can't read you writing, mate.
Right. Fumaroles are low pressure outlets of steam and gas. They usually persist for thousands of years post-volcano extinction and occur in both active and dormant volcanoes. Fumaroles emit steam and CO2 mainly, but they are known to emit sulfurs, carbon monoxide and hydrochloric acid. If they emit sulfur gases, they are called solfatara.
I see.
You can stop.
How do you stop?
So we're doing the links between lava, volcano classification and eruption classification. So first off, George is going to talk to you about types of lava.
Yes, so before we can talk about the links, we need to first know what types of lava we have. And the first one of these is basic lava or basaltic lava, in which it's largely iron and manganese based, and importantly is low in silica, which is about here-ish. And this says it only has 50% silica, meaning that it's not very viscous and so is very runny and allows gas to escape, so eruptions aren't too explosive. We then have andesitic lava, which is more acidic. This has more silica, I think 60%, and so it's more viscous and allows bubbles to escape less easily, but is not as viscous as the next lava, which is rhyolitic. And this is the most acidic of them all. It's 70% silica and is similar makeup to andesitic really. And this results in a build-up of pressure and some rather violent eruptions. And lava flows can result in such landforms as like lava plateaus, where lava flows fill up cracks in the ground to form to fill in all hollows, and so you just end up with a big layer of lava. And the two types of lava you can have are blocky and smooth ropey.
Ho ho ho.
And yes, that's what there is to lava.
Right, so I think Stuart's going to head on to types of volcano next.
Yes, so in which we start with.
Right.
No,
This week.
Yes, but this is about revision. Okay.
This week, the top 5 in the volcano classification charts are
Number 5.
basic shield volcanoes. They are formed by runny, basic lava forming gently sloping cones. They are found at mid-ocean ridges, rift valleys and hotspots like the Hawaiian Islands, where lava has direct access to the surface.
Number 4.
Acid dome volcanoes have much steeper sides due to the viscous lava. The rhyolitic lava is unable to flow, resulting in nuées ardentes, which are deadly, explosive, pyroclastic flows of superheated, glowing gases, ash and pumice, such as Mount Pelée on Martinique in the Caribbean.
Number 3.
Composite cones are alternating layers of lava and tephra, including lapilli. Most of these, like Mount Etna, have secondary cones called parasitic cones, although Mount Fuji is a classically shaped cone.
Number 2.
Ash and cinder cones are steep-sided, symmetrical, concave craters formed by ash, cinder and tephra.
And finally, number 1.
Calderas are vast pit craters, many kilometres wide, often flooded by a lake or a sea. Its summit has previously been blown off from a violent eruption, emptying the magma chamber and allowing the sides of the volcano to collapse inwards.
Okay, nice countdown there, lads. Alright, so we're going to move on to talk about the type of eruption against the type of lava you've got. So here we've got a lovely looking shield volcano full of basaltic lava. So the thing about basaltic lava, it's got quite a low silica content, which means that any gas bubbles you have can just rise straight up through it. So you only get a very minor Hawaiian style eruption with this type of lava. So eventually that eruption will cool and condense. And let's see what happens if we add some silica to the lava. So this is turning it from basaltic lava into more andesitic or rhyolitic lava. Silica content about 60 to 70%. So when you have a bubble of gas in this, because the lava is far more viscous, then the gas has a far harder time getting through. So the gas gets pressurised more and more as it builds up until eventually you get a massive eruption, a sort of Pelean or Vesuvian or Plinian style eruption here. So basic rule of thumb is the more viscous the lava, the harder it is for gas to get through and the more violent the eruptions will be. The other side of this, of course, is if gas takes longer to get through the lava, then eruptions will be far less frequent, so the most destructive eruptions only happen very rarely. Thanks for watching.
Okay, dear, the training order.
I loved it.